All right, here's day number 3 of indefinite integrals. This will be the last day for this section. And interestingly enough, we're going to get into differential equations. There are entire college courses on differential equations. It's called Diffie-Q for short, because in college, everybody shortens or abbreviates everything. So you hear people talking about, oh, I hate my Diffie-Q class. They're talking about these things. A differential equation is just that. It's an equation because it has an equal sign in it. And differential, the word differential is synonymous with a derivative. So it's basically an equation with a derivative in it. A differential equation. Sometimes you'll be asked to find a general solution. A general solution just ends with a plus c. Sometimes you'll be asked for what's called a particular solution. A particular solution is when they give you an extra little nugget of information, and using that you can figure out what the plus c is. So we're going to try both types. We'll start out with a general solution. The first and most important step when you solve differential equations is you must separate variables if at all possible. In other words, you want all the y's and dy's on the left, and you want all the x's and dx's on the right. So I'm going to multiply both sides by dx, just to knock it off of there and throw it over on the right-hand side. I'm being a little sloppy when I say multiply by, but really it has that look. All right, so now I have dy equals 2x minus 4 dx. All the y's and dy's are on the left. Actually, there aren't any y's, but if there were, they'd be over there. And the x's and dx's are on the right. All right, I'm going to integrate both sides. The integral of dy is just y. More on that later. Over here, the 2x minus 4 will become x squared minus 4x plus c. And believe it or not, that's the general solution. We're done. And it says find the solution. You want it to turn into y equals, or perhaps f of x equals. Usually we use y equals. And that's it. Y equals x squared minus 4x plus some number. Those are parabolas. And since I don't know what plus c is, it's technically a family of parabolas. All these parabolas are x squared minus 4x plus something, whether it's plus 0 or plus 5 or plus 8. But only one parabola goes through the point 1, 2. And that's the parabola in blue. So we're going to figure out what that parabola is. If the parabola goes through 1, 2, I should be able to plug a 1 in where the x is and a 2 where the y is and figure it out. It's going to be 2 equals 1 squared minus 4 times 1, c plus c. All right, that's negative 3 plus c equals 2. Add 3 to both sides. C comes out to be 5. Now, don't think that c equals 5 is the answer. The answer has to be a parabola. It has to be a y equals. But it's simply going to be the same as the red answer, except instead of plus c, it's plus 5. And that is the particular solution to the Diffie-Q, to the differential equation. I'm going to share something cool with you that I've noticed, too. Obviously, we wanted it to go through the point 1, 2, and it does. But look at where this blue parabola crosses the y-axis. That's the point 0, 5. That's the 5 that's at the end there. That's the c. Ha! It's the y-intercept. So yeah, so that's a nice pat on the back for us. Okay, so once again, general solution, there's just a plus c at the end. Particular solution, there was a plus c at the end, but we had an extra piece of information that allowed us to find it. It ends up being a number instead of constant. All right. We're going to talk a lot more about differential equations, mainly in Chapter 6. There's going to be this is just like a teaser, I guess, in a way, like a little movie trailer of what's coming later. Chapter 6 is all about differential equations for the most part. I'm not sure really why the book puts them in Chapter 4 a little bit, but hey, it's not going to hurt to see it twice, so this will be sort of light. One more thing, I alluded to this and I kind of blew it off and never came back. Some people may not be sold on the fact that the integral of dy is just y. They're probably like, how'd you get that? Especially for the people who are real deep thinkers, I just want to prove this to you so you feel better about it. You don't see it, but really it's 1 dy. And if you go backwards, the derivative of y is just 1. So it makes sense that it's going to turn into a y. But maybe you're still not convinced. Well, originally there was an invisible 1, but there was also an invisible y to the 0 there, because anything to the 0 is 1. So if you follow the rules and you go up by a power, that would be 1 y to the first. And if you divide by the new power, you're dividing by 1, which cancels. Really, you don't need any of the 1s. And you just got yourself a y. So yeah, whenever you see the integral of dy, it's just y. And that's the reason. All right, we have 4 example problems. Let's work them out, and we'll finish the section 4.1. Number 18. Find the equation of y, given the derivative and the point on the curve. Okay, so this is a particular solution. We know that x is -8 and y is -1, so we can plug that in to find the plus c. But first things first, we have to separate variables. So we're going to cruise the dx over to the right-hand side, where it joins its fellow x's. The left-hand side just has y's and dy's, really just dy's. And now we're going to integrate both sides. As we just saw, the integral of dy is y. Over here, the integral of x to the first is just 1/2 x squared, which is good because I see a bunch of parabolas, so I expect to have some squareds, plus 5x plus c. We're almost done. In fact, I'm going to circle that answer. I'll put a big oval around it. And once I figure out what plus c is, I'm just going to come back in, erase the plus c, and put in what it should be. Actually, I can cheat and see where it crosses. It crosses right here. Let's see, 1, 2, 3, 4, 5, 6. All right, it's going to be 7 plus 7, but let's just say I don't know that. Let's say the picture wasn't there. All right, I do know that I have the point -8 and -1 at my disposal. And I know that the -1 is the y. I know that the -8 is the x. So I'll have -1 equals, let's see, 64, cut that in half, that's 32 minus 40 plus c, that's -8 plus c equals 1, -1, I should say. Add 8 to both sides, and sure enough, c is 7, just as we saw from the picture. So my final answer is right up here. I just take the plus c out, replace it with a 7, and we're good. Even these differential equations aren't too hard to check. I mean, if my red answer is correct, wouldn't the derivative simply be x plus 5? It is, yeah, and I know it goes through the point -8, -1, because that's how I got the plus 7 at the end, so that's already been tested. So yeah, it's correct. Okay, instead of dy dx, I've just replaced it with f prime of x. Remember, there's 4 ways that you guys can write derivatives. If you don't like the f prime, and I don't, I'm going to change it back to dy dx. So I'll just change this to dy dx, but I'm not writing the dx. I'm going to write it on the other side. I'll save myself a step of writing. Save me some space as well. And now I'm ready to integrate both sides. College Board has these on the FRQs almost every single year. And they give you a point just for simply separating variables. So already you would have a 1 out of 5 or 6 on this problem. They're all 9-point problems, but a lot of times they'll make you solve a differential equation. It'll be like 5 or 6 out of the 9 just on that part. They also will give you a point for integrating each side. I don't know if they would give you a point for getting the y. That's kind of basic, but a point for integrating this right-hand side. Like so. Simply remembering to write the plus c a lot of times gets you a point. Even if you miss the plus c, as long as you acknowledge that you had it on the page, they're going to give you a point. And then correctly plugging in the 1, 5 to actually get the right or correct plus c is going to earn you another point. Let's do that now. That's the point 1, 5. So 1, 5. It's so easy to do this. X is 1, not y. Y is the 5. Be careful. Let's move that over where it belongs. Y is 5. X's are 1s. That's why I always write this, even though it's kind of ridiculous. I do it anyway. I just don't trust myself. All right, so you're going to get 5 equals, let's see, this is 2 plus 2, that'll be 4, plus C. C is going to be 1. So this is the answer actually right here. I'm just going to rewrite it over in this open space, but instead of plus C, it's plus 1. All right, let's check it. Is its derivative what it should be? In other words, is the derivative 6x squared plus 4x? I think you can plainly see that it is, so you can check that box off. Does it go through the point 1, 5? If you plug a 1 in, yeah, you're going to have 2 plus 2 plus 1. That is 5, so our answer has been confirmed. Sometimes you'll have a multi-step problem like number 20. They give you the second derivative, and they ask you to solve the differential equations, which means you have to come all the way back to y equals. So you have to integrate twice. No problem. Let's start out and we'll integrate both sides. Really, I should put dx's on both sides, so just forgive me. The integral of the second derivative is the first derivative. The integral of x plus 2 dx will be 1/2 x squared plus 2x plus c. All right, let's see here. I'm going to use this piece of information right here. It says that f prime of 4 is 7. So if x is 4, then this right here, if I plugged a 4 into there, would be a 7. And these x's become 4s here and here. So let's see, 4 squared, that's 16, cut that in half, that's an 8. 2 times 4, that's another 8. 16 plus c is 7. Subtract 16 from both sides. C is going to be -9. Okay, so right here, if you follow my eraser, I'm getting rid of the plus c, and I'm going to put in a -9 in its place. All right, so far we're halfway done. I'm going to erase some work. Please don't erase your work. I just have a limited video screen to work with here. All right, instead of f prime of x, which bothers me greatly, I'm going to change the name of that thing on the left to dy dx. And then I'm going to multiply both sides by the x to get rid of this dx. I'll put it over here instead. On the left, we'll simply have a dy. All right, it's integration time. The integral of dy is just y, as we've seen. All right, let's integrate quickly. Up the power, that's x to the third. That'll be a 1/6 in front of that. Plus x squared minus 9x plus c. Now, since I've already used the letter c, I'm going to call this thing d. Because people might say, well, wasn't c -9? I'm like, yeah, it was. I'll just pick a different letter. Some teachers will say c sub 1 and c sub 2. That's fine as well. And now we'll use the one thing we haven't touched yet, which is the fact that the original, notice there's no prime on that, goes through the point 6, 29. And the 29 is the y. So 29 here, all the x's become 6's. Let's see, 6 times 6 times 6 divided by 6. That's just 36. So is that. Minus 54 plus d is 29. This stuff right here is just 18, so 18 plus d is 29. I'll save you the hassle. D comes out to be 11. And so our final answer is sitting right here. I will circle it in black. I'll even put a check mark on it. I just have to get rid of that plus d and replace it with an 11. And that's it. A two-step Diffie-Q. All right, number 21 will be the last one of the section. This has been a long one. All right, here goes. It says, use the graph of f prime of x to answer and explain the following. Given that f of 0 is 2, all these questions that are being asked of us all mention f of x, but yet the graph is f prime, which is something the College Board loves to do. In fact, the only thing I know about the original graph that's not pictured is that it goes through the point 0, 2, which of course is right here. But other than that, I don't know where it is. But we're going to answer 6 questions concerning it. So here we go. Approximate the slope of this mystery graph of f when x is 1. Okay, well, slope is the derivative. And the derivative is graphed. So if you go to 1 and you go straight up, you're going to find yourself on the curve right there. And that matches up with 3 on the y-axis. So the slope is approximately 3. Okay, and that's it for part A. Part B wants to know, is it possible that f of 1 is 3.5? We know that f of x goes through the point 0,2. That's already been marked in red. But is it possible that it can go through this point as well? 1, 3.5. Which is right about there. And the answer is, no, it cannot. No. All right, so we're done with part B officially, but even though it didn't tell you to explain, I think I better do it because that is what I do for a living. So let me see if I can make this make sense. Let's say that it was going to go through the point 1, 3.5. And let's say that I got there right away from the point 0,2. Let's just say I went straight at it. Okay, well, the slope of that little segment that I made, that's up 1.5 and over 1. That's got a slope of 3/2. The thing is, however, that slope is graphed as the derivative, and you can see that the slope at 0 is not 3/2. The slope at 0 is right here. It's 8. So this thing's going up 8 and over 1. It's not always at 8. I mean, the slope is 7 and then 6 and then 5, 4. But even so, even if it was only going up, 4 and over 1, it would simply be way too high to ever hit right here. And that's why the answer is no. It's going to be too steep. All right, next up, part C. Is f of 8 minus f of 7 greater than 0? Let's go to 8 and 7 and see where we're at. At first glance, you'd say, well, all right, f of 7 seems to be a max, and f of 8 is like here. So is f of 8 minus f of 7 positive? I'd say no. But in fact, the answer is yes. Again, I owe you an explanation. Remember, this is the graph of the derivative. This is not f of x, it's f prime. And the area that we're looking at is right here, and you can see that you are above the x-axis right there. Meaning that the first derivative is positive. And if the first derivative is positive, it means that the original graph will be rising during that point. And so, going from 7 to 8, the original graph, not pictured, is moving upward. So f of 8 minus f of 7, yeah, that's going to be positive. F of 8 will be higher, so that's true, that's yes. All right, for the last 3, I'm going to go a little bit out of order. I'm going to go E, then F, and then I'll come back and finish with D. I think that'll make my explanation a little more clear to people if I do it in that order. Nobody said I had to go in order anyway on this, so I won't. All right, I want the graph of the original, which I can't see, to be concave up. Concavity is the second derivative. I have the first derivative graphed. Concave up means the second derivative is positive. The second derivative is the derivative of the first derivative, so it's the slope of this graph. So basically, part E is asking, hey, where is the slope of this graph positive? Well, that's easy. It's positive right here. Again, remember that concavity, we just use curly parentheses, not hard brackets. And that's going to end up being the interval 3 to 7. All right, part F, here's where it gets interesting. We're going to sketch an approximate graph of f of x. And to be honest, I'm going to teach a little bit out of order in order for this to make sense. I'm going to teach you some stuff from section 4.2 and 4.3 to get the approximate graph made. Maybe I shouldn't do this yet, but what the heck? You guys are bright, so I think you can handle it. So let's see what happens. Here we go. All right, to help with sketching the graph, I went ahead and colored the region in with some pretty highlighted colors, a little yellow, light green, light blue. And those areas of those shapes will tell us how many spaces our graph of f of x has either gone up or gone down by. So that's the first thing I want to do is estimate those areas. That yellow looks a lot like a triangle. If it was a triangle, the height would be 8. The base would be 2. It's not quite. I mean, it's close. The area of that triangle would be 8. I'm going to call it 7 since you can see a little bit of white that I shouldn't be counting. So that yellow area is about 7 square units. Using nothing more than estimation skills, I've got this green area pegged at about maybe a block and a half, maybe about 1.5 square units. But since the green is below the x-axis, I need to throw a negative on the front of it. And then finally, the same thing with the blue. I try to compare it with a triangle and then a rectangle, kind of going partway in between. Try to imagine blocks and count them. I decided it was pretty close to 6. Maybe 5.5. I'll go with that. Again, this is an approximate graph. It's just an estimation. There's no way to get it perfectly. All right, so knowing what I know, I start at the point 0, 2, which is already there. It's been marked for a while. It's that red dot on the y-axis. And then, as I get over to about 1.9, or wherever I change from yellow to green there, right here, I'm going to gain 7 spaces of height. I'm at 2 right now, so now I'm going to be up at 9 at that location. All right, next, I noticed that between green and blue, right here, I've lost a block and a half of height. So I was up at 9. I'm going to fall back to 7.5 from where I was, which is right about there. And then finally, when I get to the end, I'm gaining another 5.5 spaces. So I am at 7.5 right now. If I add 5.5, man, that's going to put me at 13, which is unfortunately off the page. So I'll just have to fake it. All right, let me connect the dots. Okay, up to 13. So that's a great approximate graph. And now I can go back to part D, and this is going to be easy. Approximate the value of x where the function's a minimum. Well, the function's a minimum right where it started, right here at x equals 0. It's the point 0, 2, but they just want the x value. And then from there on, it rises. It does fall a little bit because of this green area being below the x-axis, but not enough to make up for where it started from. And then it takes off again. So the answer to part D is x equals 0 is where the minimum occurs. And the actual minimum is 2. That's the y. And that's it for number 21. That wasn't quite as bad as I feared. Very nice. And I'm proud of you guys. I hope you're enjoying this and it's making sense to you. So I'll catch you in the next lesson. Take care, everybody.